So just another example here. I wanted to point out that most of the time when you see these, they might not be as simple. They might involve multiple parts. So on this problem here, the point being just that you are only going to apply those rules on the first part, right? When we take a derivative, we can split it up as the derivative of the first plus the derivative of the second. So on this one, my y prime, I have a really nice one, right? My x is just x. So I don't need to worry about the chain rule here. I would get 1 over the square root of 1 minus x squared. And from there on out, right, I don't need inverse trig. I'm back to just an algebraic function. I do want to notice that this is a product. If you're ever in doubt, imagine saying it out loud, right? How would you tell someone what this function is? You would say that it's x times the square root of 1 minus x squared. So I would have the first term times the derivative of the second. And here, be careful, right? The derivative of that second term involves a chain rule. So I would need another factor of a minus 2x. And that's only half of the derivative of that second term. I would still have to add the second. So that is going to be the square root of 1 minus x squared. And luckily for us, the derivative of the first term, the derivative of x, is simply 1. So that keeps things a little simpler. Right. Your book probably, or the AP probably wouldn't write this way, right? They would do some sort of combination, and actually it isn't as bad as it looks. This would simplify out, right? You have the half and the 2, so half of 2 is 1. Let's change that positive to a negative. That factor of negative 2x is going to cause me to subtract. I have x times x, so an x squared in my numerator, and that negative power, right, is going to put my square root in the bottom. So maybe you can see now why I kept these two written as fractions. And then don't forget the tail end, 1 minus x squared. You could probably do greatest common factors, least powers if you wanted. You could think of this simply as getting a common denominator, right? These two already have a common denominator, so this is 1 minus x squared over the square root of 1 minus x squared. And if you wanted to get a common denominator and write this as a single fraction, right, we would need nothing here, but this one would need the square root over the square root. And if you notice, right, it's the same exact value, so square root squared, I get 1 minus x squared plus, and then 1 minus x squared all over that square root. And some nice simplification happens, right? We've got 1 plus 1, so that's 2. I have minus 2 x squared, and I have the square root of 1 minus x squared. Take out my GCF. Maybe powers will help you recognize that we have like bases on the top and the bottom. First power up here, right? When you have like bases with a quotient, you subtract. So this is 2, and I would have 1 minus x squared to the positive 1/2. So all that work simplifies out pretty nicely. This is it. We are done for differentiation. If I could put balloons falling from the ceiling, I would, but I don't have them with my video here. You have now learned all the derivatives that we will learn for the semester. So we've got a running list here. Congratulations, you made it. Tomorrow we'll reverse the order here and we'll work on integrating with arcsine and arctan and arccosecant and all those good ones, our inverse trig functions. And I'll pass out a master list of all of your derivative and integral formulas that you want to have memorized for your test. So take some time now to go ahead and work on the practice problems, and we'll pick up tomorrow with integrals.